Alright, so let us proceed with the lesson 5. So what is the lesson 5? Lesson 5 is QED. Now what is QED? Q.E.D, or sometimes written as QED, is an abbreviation for the Latin phrase quod erat demonstrandum, which means that which was to be demonstrated, or it is a notation which is often placed at the end of a mathematical proof to indicate its completion. So in every mathematical proof, if you are done with proving something, usually mathematicians or students or instructors or professor write QED at the end of that particular proof to show that the proof is already complete. Alright, so now let us proceed with the postulates of Euclid. So this is somewhat connected with the Euclid algorithm. It's just that it was separated in this book, so that's why I also separate the discussion of the postulates of Euclid. So Euclid have 5 postulates. So the first postulate is a straight line segment can be drawn joining any 2 points. So this postulate simply says that if you have any 2 points, A and B, then always connect them with a straight line. So like for example, this is the first point here, and then this is the second one. So according to Euclid's first postulate, if you connect these 2 points here, it will actually create a straight line. The second postulate says that any straight line segment can be extended indefinitely in a straight line. So it tells us that we can always make a line segment longer. That means that we never run out of spaces, or which is the space is infinite. So like for example, in his first postulate, if there are 2 points, we connect it and it will actually become a line. Now on the second postulate, that particular line will have an option to be extended indefinitely. So walang ending. The third postulate is given any straight line segment, a circle can be drawn having the segment as the radius and one endpoint as the center. So earlier in the first and the second postulate, if we have 2 points, we can connect it into a straight line, and that particular straight line will have an option to be extended indefinitely. Now on the third postulate, if you have a straight line, this particular straight line can actually draw a circle, which means that particular straight line will become its radius. So since its radius, it will start at the center of the circle, and then at the the end point of that will be part of the circle. So it allows for the existence of circles of any size and center, say center A and radius AB. So like for example, in this picture here, this point here at the center is called the center A, and then this particular line segment here will be radius AB, or segment AB. Now the fourth postulate of Euclid is all right angles are congruent. So it just says that whenever we create a right angle by erecting perpendiculars, the angles created are always the same. So like for example, in here, in this particular picture, there is a straight line, and then if we actually erect a perpendicular line on this straight line at the center, automatically it would actually create a right angle. Okay, so all right angles are congruent, so it would be the same side. The fifth postulate of Euclid. So the fifth postulate of Euclid is if 2 lines are drawn which intersect a third in such a way that the sum of the inner angles on one side is less than 2 right angles, then the 2 lines inevitably must intersect each other on that side if extended far enough. This postulate is equivalent to what is known as the parallel postulate. So for every line A and every point B not lying on A, there exists a unique line M passing through B and parallel to A. So as you can see here on the picture, this one here, this line here, this one, and this one is the fifth postulate. So it says that if two lines are actually drawn which intersects a third in such a way that the sum of these particular inner angles on one side is less than the two angles, then or less than the two right angles, then the two lines inevitably must intersect each other on that side if extended far enough. Okay, so this is also called parallel postulate since it's parallel to each other. Okay, alright, so that's the end of the lesson 5.